These experimental write-ups, I need you guys to start with a hypothesis. A hypothesis is a prediction, so you guys are predicting what you're going to be doing in this experiment, or in the experiment that you're writing up. So we'll just put in brackets. The actual proper definition is a prediction based on a theory.
So that was basically.
Hypotheses are quite difficult to get right because they don't want to be too long, but they do want to encapsulate a little bit about what the experiment is about the chemicals that you're going to be using, and they also want to say what you're going to produce at the end, and that's your prediction. So in this instance, we're looking to produce a 10% saline solution. So our prediction, part of our prediction in our hypothesis, is we will produce a 10% saline solution. But we also need to say a little bit about the experiment itself. But it does still need to be brief, so it's not, a hypothesis, 2 sentences is good. A paragraph for a hypothesis is too long. A hypothesis does need to be brief. So for the experiment that we did with the titration, mixing the acid and the alkali and getting the salides, the salt. So can you see how with this hypothesis we've said a little bit about the chemicals that we're going to be using, and we've said a little bit about what we're going to do with them as well, and we've actually also included a little measurement. An apparatus diagram shouldn't be anything particularly special. Certainly don't try and do apparatus diagrams in 3D. They should just be 2D representation. An apparatus diagram that is drawn in pencil is absolutely fine. If you're writing up your experimental write-up by hand, then obviously you can draw your apparatus diagram in pencil. If you're word processing it, you can leave a gap and then go back and draw your the apparatus diagram in pencil if you want to. And you can also, if you do actually find a diagram online, that came from practical chemistry, which you think encapsulates your experiment really well, then it's also fine to use, if you do use stuff from a site which isn't yours, reference it. But what I want to see with your apparatus diagram is that you know which pieces of kit you've used, and also your apparatus diagram should show them interacting with each other. Next section, method. Now then, I have seen a couple of methods which are just a paragraph of text. Methods do need to be numbered, 1, 2, 3, 4, because they're steps. Again, if somebody wanted to repeat your experiment, they need a step-by-step guide of what they need to do it. So do put your method with numbers. Don't use the first person. I'll give you a couple of examples for what we want to do with the method. Right. Also, don't go too detailed on your method. I think if a method's over 10 steps long, unless we're doing a really complicated experiment, but if it's over 10 steps long, then that's too many steps. You don't need to start talking about putting a funnel in the top of the burette. So for this experiment, last time you could put something along the lines of first one, titrate. So yeah, that is stripped right back, but we are actually saying quite a lot in that. I could set up and run an experiment just using that one sentence. Then something along the lines of, we would need to say maybe repeat the experiment but without the methyl orange, record result, or record volume. I'm not going to say that here, but you could put that sort of stuff in. Then boil off resulting solution. Weigh salt, calculate volume of water that you need to mix it with, mix salt with water, something like that. And that's 5 steps to get to the outcome of this experiment. If we were doing this in an assignment, like I say, you might want to put a little bit more detail and think a bit more step by step as to just exactly what you're doing in each thing. But, simple is usually effective when it comes to results. Now then, the results section for an experiment is basically anything that you have measured. So you might want to put volume of acid. which it was around, say, 22.4 millilitres. And then the weight of the salt. Which was around, say, 1.6 grams. So anything which you guys have recorded on a results sheet, volume of acid, weight of salt, and actually also any calculations that you have done. So, and any equation. Yeah. So our equation for this was weight of salt times by 10 gives of water. So again, this is something else which you want to put in calculations. The results and the calculations can all go in the results section, which gives us volume of water, so all that, this conclusion needs to be linked back to the hypothesis, and you either prove your hypothesis correct or you prove it incorrect. But if you prove your hypothesis incorrect, that's not a wrong result. Yeah, it's just as valid a result as if you prove it correct. So you've proven the hypothesis one way or the other. Okay, so the conclusion is actually where sort of a level 2 experimental write-up would stop. But we have got a couple of other things that we need to think about in addition to. This is where we start to talk more generally about theories. So you can talk about, in final discussion, you can talk about the chemistry that's happening in the experiment. You can talk about when this process might be used. I mean, actually, final discussion is very much about things that, whilst you've been looking up and researching the experiment and planning on how to do it, you might spot something and think, oh, that's interesting. And you don't have a chance to put it anywhere else in the experimental write-up. But if it is interesting and it's a bit of extra information and it shows off that you know more about this than just being able to do the experiment, then include it. Yeah. Accuracy is always something that you can start to bring in experimental limitations. The peanut experiment, where we burnt it under the boiling tube full of water, is really inaccurate because you've got heat escaping left, right and centre. So that's a far from accurate experiment, and whilst we can draw a conclusion with the results that we've got, we do somewhere need to recognise that actually we could do that experiment a lot better, a lot more accurately. Yes, very much so. So you could talk about, in this experiment, for example, we used a volumetric flask because we know that they're accurate. So we're trying to minimise our accuracies, maximise our accuracies, by using accurate equipment. So we would want to say that somewhere. So experimental limitations, you could talk about. So we could say, for example, there was a potential source of inaccuracy in this experiment by not correctly measuring out or accurately measuring out our 25 millilitres of sodium hydroxide. But we tried to maximise our accuracy by using a volumetric flask.
Did you also say first time I did it that the solutions
Yes. Yeah. Good point. In terms of concentrations. Yeah, we thought, it said on the solutions that we were doing that they were 0.2 molar solutions. But they might not have been exactly 0.2 molar solutions, and that could have an effect on certainly on the results that we expect to see during the course of this experiment. Again, that's something that you can start to talk about in experimental limitations. And again, experimental limitations is an area where you can start to talk about control variables.
Temperature control.
Yeah, and actually in a lot of cases temperature is a control variable because temperature has an effect on the rate of a chemical reaction, on volumes, it affects lots of different things if temperature changes. So you could also start to talk about control variables.